All right, before we get into mod 4.4 for AGS1, we're going to do a little talk about inequalities, which I like to call alligators, because that's how I remember how they work. They work a lot like an alligator. Before we talk about how they work, let's just look at the symbols themselves. This arrow pointing to the left is a less than, and that's how you would say it. And something is less than something else. And the arrow pointing to the right is a greater than symbol. Now, the way each of these work is that you can think of them like a little alligator. Nom, 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 nom. Alligator. I don't know if I shouldn't have gone down this route. I can't make it look like it. Is that an alligator? Sure. What happens is the alligator always wants to eat the bigger number. So if I was to put a symbol in between the 5 and the 3, the alligator wants to eat the bigger number. So 5 is greater than 3 is how you would say that. The next one, -17, -9. This is almost like a trick question because a lot of people see the 17 and the 9 and they go, oh, the 17 is bigger. But since they're both negative, the -9 is actually like further to the right on a number line, which means that the alligator wants to eat the -9. So the -9 is bigger than the -17. And then the last one is 0 has some relationship with -5. Well, 0 is bigger than -5 because once again it's to the right of -5 on the number line. So 0 is greater than -5. The next section, I want to show you not just using inequalities, alligators with just two numbers, but using them with variables. Like here, I have x is greater than, x is less than 5. We can translate that to a number line. So this number line here, I'm going to show you guys how to graph that. The first thing you do is you have to decide whether or not this symbol is like a greater than or equal to, or less than or equal to. If it's just a less than or just a greater than, it's not or equal to, what you do is you find the 5 on your number line, which is right around here. On the 5, you put an open circle. So open circles are for anything that doesn't have an or equal to. So I'll make a note about that it doesn't have the or equal to. Now, the less than part of this means that x is every number that's less than 5. Less than means that you go to the right. So, to the left. I chose a great time to record this video. There's people mowing the lawn outside my room. So I would shade everything to the left of this open circle. Now, you don't have to go all the way down the number line. You can just put an arrow on the end that denotes that it's going to keep going forever to the left. So that's how you would graph x is less than 5. The next one, 3 is less than or equal to x. First of all, you would locate where the 3 is. And with this one, we would not put an open circle. We would put a closed circle because of the or equal to part. So I'm putting fill it in because here x can be 3. Oh, also with the 3 is less than or equal to x, sometimes it's uncomfortable for people to have the variable on the right. So I want to emphasize that you can totally switch this around as long as the alligator is still eating the x. So this is the same statement. X is greater than or equal to 3. That helps me realize that the number x is all the values that are greater than 3. So that has to be bigger than 3, which means to the right of the 3. So when I go to shade on my number line, I will shade everything to the right and put a little arrow on the end because it keeps going forever, all the way up to infinity. Now, there's going to be times where you have to do a compound inequality. A compound inequality means that there's more than one inequality. This statement right here, 1 is less than or equal to x is less than 7, is actually two separate statements. It's this. It's 1 is greater than or equal to x and x is less than 7. So it's both things going on at the same time. When they're compound like this, it really just means that x is everything that's in between the two numbers. So first I locate the 1 and locate the 7 on my number line. The 1 has an or equal to, but the 7 does not. So that means I'm going to put a closed circle on the 1 and an open circle on the 7. Now, everything, 1, x greater than, like the other way to say this is that x is greater than or equal to 1, and this is x is less than 7. So x greater than or equal to 1 means everything this direction, everything to the right of 1. X less than 7 means everything this way, everything that's below 7. So if I join those two regions together, that means the compound inequality is this. It's everything shaded in between them. The last thing I want to cover is how you can change alligator statements into interval notation. So interval notation is using parentheses and brackets. Nope, spell parentheses right, Jolly. Come on. There we go. Parentheses and brackets. Which we've been doing interval notation in here. We did it a lot with domain and range, where things were increasing and decreasing. So x less than 9. That means all the numbers that are less than 9 all the way down to negative infinity. So this one, as interval notation, is negative infinity all the way up to 9, but it does not include 9. So I'm going to do a parenthesis on it. So make a note that this does not include 9. That's an awful color. The next one, x is greater than or equal to negative 3. That means everything that's bigger than negative 3, including negative 3. So for this one, I start at negative 3 with a bracket, and I go all the way up to positive infinity. But remember, you can never really get to infinity, so you always, if it involves an infinity, you just put a parenthesis around it, never a bracket. Next, a compound inequality. It goes from negative 2 up to 10, and it includes the negative 2, but does not include the positive 10. So I put a parenthesis on my negative 2, and then a comma, and it goes all the way up to 10, and then a bracket. Okay, you guys, I believe that's it. Good luck on the formative today. I will help you guys as usual.